Previous lecture, we worked on this prompt template and we discussed that how we merge the fields over here. We can also merge the flows and epochs, right? And then the grounding is done, and based on this final grounding, the response is generated by the LLM model. It appears as if overall there is a prompt, and based on that prompt, we are getting a response here. So this picture I can use to show as if there is a prompt, and this prompt is sent to LLM, and this LLM worked on the prompt, and then finally it gives back the response which we are using in our flow. So this is what appears to us. But there is a lot happening in the background. So why there is a lot happening in the background? Because Salesforce wants that whatever data you are sending out to LLM, it should not at any cost cause any security breach. Okay, so in that case, what Salesforce has used is ETL, Einstein Trust Layer. Let's see how this Einstein Trust Layer works. So this is the diagram I can use to talk about Einstein Trust Layer. Now, when you work on a prompt, there is a prompt you are working on, right? So when you work on a prompt, what happens in that case is you are using some merge fields, and those merge fields are basically pointing to your company data. Like what we used in our scenario was the merge field across complaint object. You can have multiple merge fields, okay, and you might be pointing to flows, you might be pointing to apex, so all that is possible. Now consider that you are using complaint object, okay, here in your prompt template as a merge, but the person who is registering the complaint do not have access to complaint object. In that case, my prompt template would not be able to fetch the data. Why? Because everything in the prompt template is coming under Einstein Trust Layer, and in the Einstein Trust Layer, one of the block is secure data retrieval. If the user do not have access to the complaint object, he or she won't be able to fetch the data to be used in his or her prompt to send across LLM. So this is one of the feature. Okay, next is the dynamic grounding. So every time when you work on the prompt template, we have just seen that we can embed the logic so that it remains dynamic. We can always fetch the latest data, and we need not to work on the latest retrieval. Also, it gives the reusability. So this is also possible because of the Einstein trust layer, which comes under Einstein 1 model. Then is the data masking. Now, when we have something which is very sensitive, we call it personal information, right? Let's say you are using some email ID, for example. Then you want that email ID to be masked before it is sent across the systems, before it is sent across to LLM models. So what that is what we are taking care in Einstein trust layer. So in our example, we are merging the fields from the data. Let's say we want to hide the pin code for which the complaint has to be registered. So anytime we can go to complaints, and here if you go to the object level, let's say, so when I look at the pin code, there is two more attributes which are data sensitivity level and compliance categorization. So let's talk about what this is. To understand these two terms, we need to look at Einstein trust layer. So go to setup, and under Einstein generative AI, we can go to Einstein trust layer. Okay. So it says that large language model data masking. Do you want to enable data masking or not? So now we have enabled the data masking. So this is how you enable the data masking. And then before you begin, it says there are two types of data masking. One is pattern based and the other one is field based. In the pattern based, Salesforce itself recognize some patterns. Okay, so for example, you can say as if some email field is in use, okay, or some currency field is in use, then it what it does is it basically mask that value, and then it's sent to LLM. In the field based masking, we decide which fields are there on which we want to do the masking. So here you can see that Einstein trust layer model use pattern and context to identify sensitive data in prompts. So as of now, name, email address, phone number, credit card, these are used as the sensitive data under pattern based. If you want to enable or disable one or more, you can control it from here. Okay, and then there is a field based. In the field based, what you do is you have various categories available like PII, HIPA, GDPR, PCI, right? So let's say we want to hide the uh, pin code. So in that case, I can enable this GDPR, and over here I can assign this GDPR to this one. Okay, and then I can save it. And then you have the third option here, which is the data sensitivity level. So let's say we are making it a confidential. So you can assign confidential to the pin code in the data sensitivity level, and then you can save. So this is how you can control the field level masking. And in this, we have now understood data masking. And next is the prompt defense. So whatever prompt we are sending, what Salesforce will do, Salesforce will add some prompt defense. Okay. Why it is doing prompt defense? It is just trying to make sure that before I reach out to LLM, I give some basic instructions to it so that it does not send to me any inappropriate toxic data. Okay. So some prompt injection is done, some content is added in the prompt so that the LLM behaves in a right way. So that is called prompt defense. It is a defensive technique in which we make sure that when we are interacting with the LLM model, we are giving some instructions in our prompt so that the LLM model gives us the appropriate answers. And if it does not know the answer, instead of giving any inappropriate answer, it should say, I do not know the answer. So that is a kind of prompt defense mechanism which is in used for Einstein trust layer. And then finally, through this secure gateway, it is going to the LLM model, and LLM models which comes with Salesforce, they have zero data retention agreement with them, which means that they cannot keep or store the prompt as well as the response or any other data with them. They have to make sure that nothing can be retained, and everything which they have sent should come back without any retention through the same gateway. So this is important. And once here we have the response available, the response goes through various channels. In case the response is toxic, it is detected as part of toxic language detection. Okay. And there are various rules, I can say, which are defined for this. So let's talk about them. Now, if I move to the next layer, safety and security, it talks about toxicity detection. So now there are two level of toxicity detection. One is in the beta, which is for toxicity detection in prompts. You can enable this one as well. If you do this, your prompts will also go through toxicity detection before they reach out to LLM. But if you don't enable it, this is still in the beta phase, but if you don't enable it, the other one, which is the toxicity detection in responses, is already enabled. Okay, so it says that it evaluate response for toxic content, and whatever it finds out based on that response get a score, and that score is always get into the audit trail. So you cannot change it, it is enabled by default. And here we should also know what is basically toxic. So anything which is harmful is toxic, like having violent, abusive, hateful, or sexual language. Okay, imaginary or themes that carries a risk of harm to individual or groups. So all this comes under the harmful content. So Einstein trust layer gives a score, and you can read that score in your flow. You can read that score, and based on that you can decide whether you want to go ahead with a response or you want to generate a new response. Because no one, I don't want to send out an email, okay, which is toxic to government authority. So I can check that score, and accordingly I can decide what to do. So now let's get back to our diagram. Once the toxic language detection is done, the next part is data demasking. In data demasking, whatever data we masked over here, that is demasked. Okay, and then everything get captured in the audit trail, and finally it is shown here as a final response. So it becomes the final response. Okay, so this is how Einstein trust layer is making sure all the data is secured, everything is safe, there is no retention. Now, one important point is if you use any LLM via any custom API call, let's say you have your Apex class where you are using API call to LLM. If you're making a call to Chat GPT, that is not where Einstein trust layer will play any role. In that case, Einstein trust layer has no role to play. So it comes into picture when you use prompt template or model APIs.